Okay, so that's most of the stuff in 4.2. Now we're going to go to 4.3. We're going to talk about a rectangle, square, and the rhombus. R-H-O-M-B-U-S. Definition. A rectangle is a parallelogram. But it's a special kind of parallelogram that has a right angle. Now this may seem like an odd definition because when we think of a rectangle, we think of the rectangle as having all four sides, or all four angles to be right angles. Well, it turns out that because of this definition, this actually implies that this will also occur. So a corollary that comes from this definition is what we normally think of. All angles of a rectangle are right angles. And this comes because if we have a parallelogram, and this is a right angle, let's say this is the one that was right, well, we know that the opposite angle must be a right angle, so this one must be a right angle. We also know that these are parallel, the top and the bottom are parallel, and so these angles must be supplementary, so that means this one's a right angle. Well, also that means the opposite angle, this is a right angle. So by the definition of having one right angle, it actually implies that all of them are right angles. A theorem about rectangles. You might use this to solve a problem. The diagonals of a rectangle are congruent. Okay. Another definition. A square. Well, a square is a rectangle, which means it's also a parallelogram because a rectangle is a parallelogram. And a square will have all right angles, which we think of. And then what else do we need to know about a square? So it's a rectangle that has two congruent adjacent sides. Again, this is a little different than what we think of when we think of a square. Okay, so we think of a square as something like this, and we know that from a square we know that all the sides are congruent, but the definition only determines that two of them are congruent. But because it's a rectangle, and because it's a parallelogram, this top side must also be congruent to the bottom side, and likewise the left must be congruent to the right. So a corollary from this definition is what we typically think of as a square. All sides of a square are congruent. It's a little important to notice that our definitions are perhaps a little different than what our intuition or what we've learned so in the past about a rectangle and a square are. Yet, because of the way these are defined, corollaries sort of determine what we normally think of as rectangles and squares. It's important to notice that. I'll move on to the next quadrilateral that we'll study. And Nathan, this is for you. You asked about this in class a while back. A rhombus. Well, it's kind of like a rectangle because it is a parallelogram. But instead of having a right angle, a rhombus is a parallelogram with two congruent adjacent sides. Kind of like the definition of a square, except it is not a rectangle, it's a parallelogram. So in general, a rhombus might look like something like this, where all the sides, well, the definition says that two adjacent congruent sides. So this side is adjacent to this one, and those must be congruent. But like before, we have a corollary that says, because of this, because it's a parallelogram, this side must also be congruent to this side, and this side must also be congruent to this side. So in fact, the corollary is that all sides of a rhombus are congruent. Important to notice the difference between a rhombus and, going back to the section before, a kite. Remember when we said kite, the kite must have two distinct pairs of congruent adjacent sides. So this pair must be a different length than this pair. Because if they are the same, then it will actually be a rhombus and not a kite. And we have a theorem about a rhombus. The diagonals of a rhombus are perpendicular. If we were to draw these diagonals, if my drawing is somewhat to scale, then we can sort of see that these two diagonals are perpendicular to each other. I believe there's some proofs in your book. You should check those out. So there's three definitions, three corollaries, and two theorems about a rectangle, a square, and a rhombus. Also, finally, in this section, we do revisit the Pythagorean theorem. I think we've already covered it a little bit more, or a little in the past. But the Pythagorean theorem says, in a triangle, with hypotenuse of length C and sides of lengths A and B, we have the relationship that A squared plus B squared is equal to C squared. The square of one side plus the square of another side is equal to the square of the hypotenuse. I believe this comes up, I'm sure you've all been exposed to it in the past, but I believe it comes up in this homework section.